everybody. All right. So, what is in store for Halloween week? Look right here. Coming up on the screen. All right. Algebra 3. Let's see what we have this week. Go to my grade screen up here. Scroll down. This is November 6th, is this coming Sunday. So, that's the week we're on. First, we have a quiz, Module 3 quiz. I've already taken my quiz. So that's a quiz over the first 5 lessons we already have. So make sure and get your quiz done. In fact, I don't think Buzz will let you move on until you get the quiz done. So get the quiz done. And then graphing polynomial functions is our only lesson this week. So you see next week, we're finishing up the modules. We've got the practice test and then the test for next week. So this is our last lesson, and it's on graphing polynomial functions. So that'll be somewhat easier, right? We know graphing somewhat, but we're talking about polynomial functions. We're talking about all kinds of functions, not just lines or quadratics. We're talking about all kinds of stuff because we've gotten into some big equations in this unit. So let's take a look at that. Go back to the activities and look at graphing polynomial functions. What all does that entail? So it does have a short video, minute 43. I'll let you watch that on your own time. It's like a little cartoon thing. After completing this lesson, you'll be able to answer the following questions. How are solutions of a polynomial function connected to the graph? And what key features can be identified from graphs of polynomials of higher degrees? It's the third power, the fourth power, the seventh power, the eighth power, higher degrees. So graphing polynomial functions without technology. You should be able to do this. You shouldn't have to have Desmos or a graphing calculator to be able to graph any equation, because you can always make a table and get some X, Y points, put those on the graph and connect them, right? Graphing a line, this is reviewing just graphing a line. If you have y equals 1/2 x plus 5, you can choose some x coordinates, substitute those into the equation. X equals -6. So it'd be 1/2 times -6 plus 5, -3 plus 5, y would equal 2. So that gives us the point -6, 2. So you put a 2 there in your table. This ends up 3, 4, 5, 6. So you get 2, 3, 4, 5, 6. Then you would graph those points. -6, 2. Let's see, make that bigger actually. -6, 2, -4, 3, -2, 4, 0, 5, 2, 6, and then connect them. Connect them with a solid line. So we can graph that equation. That is the equation. Y equals positive 1/2 x plus 5. Can do that. You could also have done that by taking the y-intercept, because you know it's a y-intercept of 5, because that's mx plus b, and then using the slope of 1/2. So you would graph your 5, 0, 5 is your intercept, and then go up 1/2, and there's your next point. And then you can connect those and make a line. So you can do it just off the rise over run and the y-intercept, right? We don't have to have technology to graph a lot of these things. Graphing a line. Look at a parabola. The parabola, here's y equals 2x squared minus 8x plus 7. We could graph that. Find the x coordinate of the vertex, right? Because we can do that -b/2a. That gives us that the vertex is at x equals 2. We substitute that back into the equation, and that tells us y equals -1 when x equals 2. So that's the vertex. So we know where to put the vertex. Then we can make a table for other values. We know the vertex is at 2. So we put a couple of values on either side of that, 0, 1, 3, and 4, since we know the vertex is at 2 now. Substitute the x's into the equations, 0, 1, 3, and 4, to get what the y coordinates are. And there are 7, 1, 1, and 7. And just take those points, put them on a graph, and then connect them. A lot of you guys have been putting these points on the graph, but you haven't connected them. If it's a quadratic equation, you know it's connected. If it's a linear equation, you know it's connected. Most of the times, these equations are connected values. It's not just the points, because actually this graph exists at 2.5 and 2.8 and 2.1 and 2.05. What is the y for all of those values in between 2 and 3? Well, they exist because you can substitute 2.65 into the equation to come up with a y. So if you don't connect it, you're saying there's nothing between 2 and 3, and that's not correct. So you need to connect your graphs. And generally we put an arrow at the end, but if it goes to the end like that, that assumes there's an arrow there. All right, so that just shows a little review on a line of parabola. How about graphing higher degree? Like here's a cubic one. F of x equals x to the third. Well, again, we can make a table of values. We'll choose a couple of negative values, 0, and a couple of positive, -2, -1, 0, 1, 2. Substitute these in for x. -2 to the third power would be -8. See, -8. -1 to the third power would be -1. 0, 1, 8. Then you got your table filled in. You go and you plot those on the graph. There it is. -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. And we connect those. That is the graph of x to the third. Should be able to all these graphs without having to go to Desmos. It's a useful skill. And then shifting functions. Remember, if you have a x plus a c in parentheses, you're like x plus 1, x plus 3. That's going to shift it to the left 3 units. If it's x minus 3, it would shift it to the right 3 units. If you have just a constant at the end, you got x squared plus 2, or you got x to the fourth minus 1. It just shifts it up and down. Plus 2 would go up 2, minus 1 would go down 1. Anytime there's just a constant added on to the end of the equation. If it's multiplied times the x or multiplied times the equation, that's going to make it wider or more narrow, depending on whether it's greater than 1 or less than 1. Maybe your c is a half, and you're making it by a half. So it's going to bring it narrower. And it'll do the same thing if you multiply it times the function on outside, wider or narrower. All right, it says graph the function x plus 2 to the third power. So find the x coordinate of the turning point. Right? Still, that's when x equals, when this equals 0, x plus 2 equals 0. So the turning point is going to be x equals -2. That's the turning point for the x third. What do I mean by turning point? Well, remember, look at this. This is x third. So right there is the turning point. It's not exactly the vertex because it doesn't change there, but it turns. It turns and it goes up again. So they call it the turning point for a third equation there. So select your table again, find your y coordinates for the table, graph your points. And it's basically the same graph, but that x plus 2 moved it left 2 points from there. It was right there in the origin, and now it's moved. Every point is moved 2 to the left, which we would expect it to do because the x plus 2, as we looked at up here, shifts units to the left. So we expected that. A quartic function, fourth degree. F of x equals x to the fourth. Again, our table of values, -2, -1, 0, 1, 2. Substituting those numbers into the equation. Like I said, that is a really big skill in math and algebra, being able to substitute in and get an answer. When you take -2 and you substitute it in for x to the fourth, that gives you -2 to the fourth. -2 times -2 times -2 times -2 equals 16. So when x equals -2, y equals 16. We just substitute it in for the x and see what the y equals. So we do that with all those points on the table. We come up with this, and then we can plot them on a graph. It looks a lot like a quadratic function, but this is a little wider down here. This is wider. Kind of spreads out a little bit. X to the fourth. X to the fourth is similar to x squared. X to the sixth would be like this also, but it'd be even a little bit wider. X to the eighth would be a little bit wider. Any even number is going to have the same overall shape. with just a few differences. Okay, so x to the fourth plus 3. Right? It should be the exact same graph, just plus 3. Everything will go up. If we look at it, everything just went up 3. Right? Just adding that plus c on the end just changes vertically how it's going to look like that. So, all right. There's another video down here. I'll leave for you to watch. It's only like a minute and a half, minute 34. And now it wants to know about end behaviors. This is a good one. If we have f of x equals 4x to the 23rd power minus 5x squared minus x plus 7, what is the end behavior? It's like, what do you mean by end behavior? Well, let's see. For end behavior, we're talking about what do the ends do? Do the ends both go up, the two ends of the graph? Do both the ends go down? Does one go up and one go down? Or does it go the other way? Maybe the flat one goes down and this one goes up. Got 4 different possible end behaviors for our graph, right? And it wants to know if we had a 4x to the 23rd power, what would it do? How can we know? Well, there's a little trick to that. If it is even, the exponent, if it is even, then you have this case here. It's either going to be up or down, but they're going to be the same. Both ends are the same. See, both of those ends are going up. They're both the same. Now, what determines whether it goes up or down is the coefficient positive or negative. If it's positive, they're going to go up. If it's negative, they're going to go down. So we can look at the 23rd. That is not even. That's odd. So that throws us over here. And with an odd function, you're going to have either this case or this case. All right? We got a chart here. A chart right here. If you have a positive leading coefficient, this one goes down, this one goes up for an odd function. If it's a negative leading coefficient, then it goes up, then down. So this is a negative, this is a positive. And if you have a hard time remembering that, it's the right side that helps you remember. The right side. This right side is going up to the positive numbers. That's when the leading coefficient is positive. This one is going down to the negative numbers. That's when the leading coefficient is negative. It works the same on the even ones. This is a positive. The right side is going positive. This is a negative. The right side is going negative. So the right side always helps you determine whether it's going up or down based on the sign of the coefficient. See, this coefficient right here is positive. That's a positive 4. So we know it's going to look like this. It may do a whole bunch of real funny stuff in between, but the very end of this graph is going to be pointing down, and the right end of that's going to be pointing up. So that positive 4, put you on this graph, the 23rd, make sure it's the odd one. To the 23rd power. So this is the nice thing to put in your notes. End behavior of a graph of polynomial function. Wonderful thing to have in your notes. Because remember, you can use your notes on all the tests and assignments and everything. So if you had that in your notes, save you some time. Okay. Let's look at the next page. Now we're going to talk about graphing with technology. All right. So you may need to customize the view of the graphing area. Sometimes it may not show enough of the graph. You may need to zoom in, zoom out. Make sure you understand how to enter an algebraic equation to be graphed. Right? If you want 5x to the third, we got to type this 5x with that little caret to the third. If you type it in wrong, you'll get the wrong graph. And make sure you understand how to save your graph as a picture. If you need to turn in a graph of it, you can take a screenshot or whatever you need to do, and find the help menu for any functions you can't figure out. So let's look at examples here. It says graph this function. F of x equals negative 4x to the fourth minus x to the third plus 13x squared plus 4x minus 8. Well, we know some things about it already. It's negative 4, so that means it's going to be pointing down on the right end. It's an even, the largest exponent is even 4, so that means both ends will be pointing the same direction. So both ends of the graph will be pointing down because it's a negative. All right, so when you graph it on Desmos or wherever, here it is. And look, both ends are pointing down. Now, it did some funny stuff in the middle. It went up and down and up and down. But the end behavior, we knew already what it was going to do because it's an even powered exponent, even exponent, and a negative coefficient. All right, see, the end behavior is correct. Far left and far right continue down. Coordinate plane. Now it says this one. How about graphing this using graphing technology and describe the end behavior? Well, let me put it over here. Oh, didn't copy. Copy. Okay, so I got to put the little rays up in there. What do we expect the end behavior to do? This is, well, this is negative 3x to the third. It's odd, so one end's going to be up, one end's down. It's a negative, so that means the right side's going to go down. The right side's going to go down. All right, there it is. Negative 3x to the third plus 4x squared minus 4x plus 2. Here it is in our graph. The left side goes up, the right side goes down because it's an odd function and it's negative. So the right side's going to the negatives. All right, so if we check our answer over here, look, there's the same graph that we just made in Desmos. This one only has one real zero, you can see. Oh, that's the only real zero. It does have 3 solutions because it's to the third power, but the other 2 are imaginary. They are complex solutions. There's only one real one because it only crosses the x-axis once. All right, so let's look at what they have on the next page for us. Solutions of polynomial equations. This is review on solutions. It's slow opening there. All right, I'm going to skip that review. You can look at that a little bit. The x-intercept of any linear quadratic equation is found by substituting 0 for y and solving for x. Right? Solutions are called the zeros of the function because that's when it actually equals 0. See, that's when the function equals 0. The y equals 0. The y equals 0. So these are called zeros of the function or solutions of the function, or also x-intercepts of the functions. This will apply to all polynomials of a greater degree of 2, like cubic or quartic functions. Let's see. So when you graph that, again, that's our graph. This is a third degree. And it's obviously a positive coefficient because it's going to the positives on the right side. X to the third, so positive 1, minus 3x squared minus x plus 3. And so we find the 3 zeros. So here's another one. Or is this the same graph? That's the same graph. It crosses in 3 places at negative 1, 0, 1, 0, and 3, 0. So that is the 3 zeros. That is the 3 solutions, negative 1, 1, and 3. The 3 x-intercepts, all by graphing. Instead of having to do factoring and synthetic division and all that, by graphing, we can just go straight to the answers right there. Let's check your answer. Substitute those in to check. 0 equals 0. Solutions of polynomial equations. It gives you another box on that. It says approximate the real number solutions of this. 2x to the fourth minus 8x to the third plus 9x squared minus x minus 4 to the nearest 100. So it has it graph it. And then see, it doesn't exactly land on a 0, 1, 2, or 3 thing. That's why it says to the nearest hundredth. So let's put this in Desmos and see what those numbers actually end up. Okay, I got to make that to the 4th power, to the 3rd power, squared. All right. Here is the graph. So the solutions, and there's actually 4 solutions because it's to the 4th power, but 2 must be imaginary because there's only 2 on our graph. So this is negative 507. It's one of the solutions. And the other solution is 2.305. Now this asks us to the nearest hundredths. So tenths, hundredths. So it's a negative 0.51 and 2.31 because this goes to the thousandths. So we just round that up. But that is the solutions. Easy to find by graphing, would hard to be due by factoring or synthetic division because it's not a nice, easy number. So graphing gives us a nice, easy way to get the solutions to that equation. And knowing that the other 2 are both imaginary solutions. All right, find the x-intercepts. So we found the x-intercepts on there. Adjust the number of decimal places, negative 0.51 and 2.31, and then verify the solutions by substituting them back in there. To verify those, put those back in, solve it, and see if it equals 0. Well, it's really close, but we rounded, so it's not going to be exactly 0. These are approximate solutions. Okay, so here's another one. Graph that to the nearest hundred, see what the graph will look like. Here's what the graph looks like. There's only one real solution. One real solution, even though it's to the 3rd power. So it has 2 complex solutions. Has 1 positive real solution. And you can check it by seeing exactly what it equals. 1.72 is the solution when x equals 1.72. So, all right, so graphing helps us a lot to be able to solve these without having to do all the factoring and other stuff. Key features, average rate of change, right? What is the average rate of change between 2 points? This one says between x equals negative 4 and x equals 4. Well, let's look at this. When x equals negative 4, the graph equals 0. When x equals 4, the graph equals 0. So the average rate of change between x equals negative 4 and x equals 4 is 0. It's 0 over 8 because the x changed to 8, but the y was still 0. So it's 0 is the average rate of change between those 2 x's. Also between x equals 0 and x equals 4. That's also. Or x equals 2 and x equals 4. That's a 0 rate of change. It went down a bunch and then it came up the same amount. So the average rate of change was 0. Increasing versus decreasing. So if we look at this, here, let me be able to mark on this here real quick. Let me pull this up. My highlighter, it's increasing right here, right? Then it stops increasing because now it's going down. But down here, it starts increasing again. And down here, it starts increasing again. So in any of those yellow areas, the graph is increasing. So this is from negative infinity up until about negative 3.3 maybe. And then from negative 1 to positive 1, positive 3.3 to infinity. Those are all areas it's increasing. And when we talk about intervals of increasing, we're talking about what intervals of x, right? Between what points of x? Well, between where x is here and between x is here. That's increasing. Negative infinity all the way up to there. From this point all the way to infinity. That's the intervals that it's increasing. And of course, the decreasing is the other intervals where it's going down. There's only 2 intervals where it's going down. So see what they say about it. Okay, so they show the 3 increasing intervals and the 2 decreasing intervals. So minimums and maximums. See, this is a minimum, this is a minimum. But it's just a local minimum. It's not the absolute minimum because the absolute minimum would be the absolute lowest point of the graph. Well, this graph goes to negative infinity. It doesn't have an absolute minimum, but it does have a couple of local minimums and a couple of local maximums. I'll show that right there. See, that would be a minimum. That would be an absolute minimum. These are just local minimums, local maximums, because there are higher and lower places. This goes to infinity, goes to negative infinity. Okay, this one wants you to calculate the average rate of change between x equals 0. When x equals 0, it's 3, and x equals 2. When x equals 2, it's negative 3. So how much did it change? It changed negative 6. How much did the x change? The rise over the run. The rise over the run, right? It went. The rise is negative 6, and the run is 2. Negative 6 over 2 is negative 3. Rise over run. So the average rate of change between x equals 0 and x equals 2 is it goes down negative 3 every time x goes up 1. Negative 3, negative 3. Okay, and this just reviews what we already talked about. X minus h, where it'll shift it over right and left. And here's your lesson summary. So this would always be where I would go for my notes. I would get all this lesson summary, make sure I've got all of this in my notes. I could print this out and put it in my notes. I can screenshot it, put it in my notes, however I want to do that. Write it down. And this is the lesson summary. So then there's a couple pages of practice problems, so you can practice more to see if you know what you're doing. And that is all of the lesson. All right, so of course after that, there'll be the assignment that goes with it, which is multiple choice, 5 multiple choice. So you have the quiz and then this graphing assignment, which is 5 multiple choice after you go through the lesson. So we looked at a lot of the lesson already. So that'll give you a good overview. But go back and watch those videos because it's got some good explanation. They're like 1.5 minute videos. Watch those videos. Read through the parts that we didn't read. We didn't read everything. So make sure you go through your lesson and can knock this out. So I won't keep it any longer. Happy Halloween, everyone. Happy Halloween. Enjoy your evening. Eat lots of candy, all that good stuff. And we will see you next time.